So there are a few concepts that I'd like students to pick as early as now, and these concepts will help them in future as they study and even as they head into practice. So the the modern day inverter, the all-in-one unit, is a system that is one component, but inside we've got three or four other subcomponents. So number one, we've got the inverter, which is the bulk of the unit. That is, the main purpose is to convert DC power or DC into AC. And then we've got another unit inside that component that picks power from the panels in DC form and rectifies it, smoothens it, stabilizes it, and releases it into the battery to charge the batteries. And then we have got another component that picks power in AC from the grid. These are inverters that are connected to the grid. It picks AC from the grid, converts it into DC, and uses it to charge the batteries again. And we've got another component. It's not in all inverters, but we've got another component that will pick AC, use the pick AC, both AC and AC from the grid and AC from the what the inverter has now converted from the batteries, balance it, and releases it into the loads. So after a student has done the installation part, for example, this is a system that is existing. The electrical installation part is an existing part, and the inverter is now the new system that is now joining the electrical installation, or the solar PV powered side is now the new system. Now it's supposed to join the electrical installation. So a technician has done the electrical installation. He's done all the tests, both the dead tests and the live tests using the grid power, and they're all okay. So essentially, after doing that, you are supposed to switch off everything from the last switching point. So if, for example, what I mean is that if you're supposed to switch off all circuits or all final circuits and accessories and whatever. So for the lights, ensure that the switches are off. For the 13 amp socket outlets, ensure the switches are off. For the fixed units like the cookers and everything, just ensure everything is off in a system. Then you've now this is after you've finalized the installation of the PV powered side, the inverter, the batteries, and the solar panels and everything. So after you've switched everything off and you want to commission, if it were the AC side, let's just do a brief step by step if it were commissioning an AC system the right way. So what you do, you go to the meter intake point the client's intake point at the meter cabinet, and you plug in your cutout, the fused cutout. You plug it in, and then if the insulation has got an isolator at the intake point, you switch on that isolator, and then you proceed, head over to the consumer unit, the main switch of the consumer unit, switch it on, and then you now start from the smallest MCB, or the smallest load on that consumer unit. You switch it on, and then you locate the circuits attached to that small MCB. So you go find each and every circuit attached to that small MCB or connected to that small MCB, and you switch it on. So for instance, if these were lighting circuits that have been branched, for example, in 2 or 3 rooms, after you switch on that small MCB, you go into all those rooms, you switch all those lights on. Then you go back to the consumer unit, switch the second MCB on, depending on whichever circuits, then repeat the same process, find the circuits, switch them on, and leave them on. And you do this slowly by slowly, progressively, from the smallest load all the way to the biggest load. That is how you commission a system, and ensuring that the grid is not so for the grid systems, because the grid normally has got an allowance for all these inconsistencies to happen, because some loads, the grid will listen to both linear and non-linear loads, linear and non-linear loads, and balance it itself. So the grid has been modified to ensure that if all these loads are coming in at the same time, it will balance itself slowly and stabilize. The grid has got an allowance for that. So if this were the same case with an inverter or a solar PV powered system, you do not always just switch on loads uh, the same way you were to switch on the grid connected system. Remember, for a grid connected system, if for example there's a blackout, you can just leave everything on. When the power is restored, the grid will stabilize itself. The grid is big and it has got an allowance for that. But for your small load, for example the inverter, not load, for your small system, the inverter has got small microelectronics that normally have to listen keenly to the load profile and adjust so that to ensure that they are delivering a pure sine wave that will match whatever the loads demand. And this is in a case where you have got both linear and non-linear loads connected to the same inverter. If you were to do such an installation, how do you commission it, or how do you ensure that now for the first time you want to release power into the loads, you are not sending the wrong load profile into your inverter system? So this is what you do. You head to your inverter, switch everything off on the installation, ensure that everything is off first, then go to your inverter, your all-in-one inverter, find the connection between the inverter and the battery, power that on, or allow communication to happen between the inverter and the battery first. So here we have agreed that everything is off entirely. So the first thing to come on is the connection between your inverter and your battery. So give it at least a minute to stabilize. Let the inverter read the information the battery is sending. Let it understand that information first, and this is after you've ensured that the communication is okay. The inverter is has been programmed to this particular type of battery. So if it's a lithium gel, but that's a different topic, we've covered it. After that, the inverter is stabilized. Find the connection between the inverter and the solar panels. Switch that on. Allow the solar panels to send power into the inverter. Let them at least communicate for at least a minute or so. We are not in a hurry, so at least a minute, between each session is okay for the inverter to just stabilize and understand whatever is happening. So now you've switched on the battery. The inverter has understood the battery state. You switch on the solar PV panels. The inverter has understood that probably that it's during the daytime and the panels are generating this amount. And then you head over now to switching on the loads. So at this stage, we have agreed that the consumer unit is off. Everything is off in that installation. So you switch on the first switch between the inverter and the consumer unit. If there's an isolator, whatever you've used to this whatever accessory you're using between your inverter and your consumer unit, switch that on, and then head over now to your consumer unit. If it's not in the same location with the inverter, switch the main switch on or put the main switch on. Now, technically, there is power between the inverter and the main switch, but not into the loads. So we now redo the same process. Go to the smallest load or the smallest MCB, switch it on, go into the house, find the loads connected to that small MCB, switch all of them on. Ensure that they are all on. Go back to the consumer unit. The time you take between the first MCB and the second MCB will vary between a minute or and a half to 2 minutes, depending on how far the MCB is from the loads. So in essence, if there's someone else helping you, like let's say there's someone else at the consumer unit who just does the switching, and your work is to find these loads, tell him to at least wait for at least a minute or two before switching the second set of loads on. So you switch the first MCB on, wait for a minute or 2 minutes, switch the second MCB on, wait for a minute or 2 minutes, switch the third MCB on. And while this is happening, you are finding these loads wherever they are and switching them on. So what this does is that by the time you switch these loads on progressively, You switch an MCB, find its loads, switch them on. Come back, switch the second MCB, find its loads, switch them on, all of them. Come back, find the third MCB, like that. By the time you've finished doing that, the inverter progressively reconfigures itself, or to ensure that the wave it's generating, the sine wave is generating, is is meeting the actual demand of the loads that are being plugged into the system. So this way, the inverter will not suffer from concepts like inrush currents or false tripping. So, for example, some of these loads, because we've looked at loads in a different topic and understood that loads are not the same. Some are linear, some are non-linear. So the way they behave on the sine wave is different. Some will lead, some will lag. But when you switch them on progressively, the inverter readjusts itself to ensure that the next set of loads coming in, or the loads that have already been introduced to the inverter, their demand, the inverter restabilize or reconfigures itself to ensure that it's meeting the demand of each and every set of loads coming in. Do not, what I normally see is that technicians normally install their system. After installing, they just find the second largest, not largest, but after installing, for example, the inverter or the solar PV powered system, and they've connected it to the consumer unit, what they do is just all loads are on, they just come and switch on the main switch or the isolator between the inverter and the consumer unit. The modern day inverters are depending on several microelectronics. Some of them are so sensitive to instability, both the in and outgoing instability. So if you shock it, or if you ambush it with these several load profiles, the inverter, if it won't trip, it will reconfigure itself falsely to now forward, and it will never be able to readjust its actual parameters to ensure that the sine wave being generated will always meet the load profiles of that particular installation. So this also raises the question of, if you have a variety of loads, and this is not for the domestic sector, normally most loads, the difference is not normally high, but for commercial or small scale industrial settings, there's normally a difference in the load profiles. Some are linear, as linear as what the inverter will generate, and some are way non-linear. So if all these loads are supposed to be connected to the same inverter at once, the inverter will, in less technical terms, say misbehave and fail to reconfigure to serve all these loads as expected. So during commissioning, let the inverter at least understand the loads independently as they are being introduced into the system. In any case, if this system is supposed to keep running, also you should have a mechanism whereby if you're reintroducing loads, every time you have to introduce loads, there should be a timer that or a timing mechanism. So now, thank you for listening all through. If you enjoy these sessions, if you are learning a thing, kindly, you can share, you can interact, you can comment. Let's see what else to talk about. It's a holiday season, and we'll be out of class, so out of the physical class, but not the learning sessions. So the learning sessions will be continuing. Let's see what we can talk about. If you have a question, if you're a student, a technician, and you have a question and you think we can talk about, let's share, let's interact. If you can watch more of these clips on YouTube, have our YouTube channel. You can watch some of these videos. Let's interact.